It doesn't always rely on the previous problem when it comes to these two-parters in terms of like using the expression, but in this case, it's actually very helpful because knowing that 22 is b, we can actually rewrite this problem as r squared equals p over 4 pi times I. And then we're going to call this observer A, and then observer B, we'll see r squared equals that same equation, 4 pi I. And now what I want to do is replace A with what we see that we're comparing it to B. They're saying that A is 16 times the intensity of observer B. So we can put 16 here where this would just be 1. And if we want to know what is the fraction of the distance between the two, well, if we have a radius squared here, what would make this a lot easier is if we just square rooted, this, and then you end up with just R and R. But whatever you do to one side, you do the other side. And when you're square rooting a fraction, the best way to rewrite that is each term gets their own, because everything's being multiplied here in the denominator, I can just write one little house for each of them. And ultimately, this is what we care about. All these others are going to be the same, so we don't really care about all this. All we care, what is the difference between this and this? And so what you end up with is this turns into 4, this turns into 1, and ultimately we see 1 and 4, and that lines up with a 1/4.